All right, so today's lesson's on arrays. We're actually going to go all the way back to slide number 1 to start our lesson. So multiplication is a short form of abbreviation for addition. For example, 3 times 5 equals 5 plus 5 plus 5. So we've got it showing us there. So we're going to practice this. It says write these multiplication statements as addition statements. So we have 3 times 2. This means we have 3 groups of 2. So we would write that as 2 plus 2 plus 2 3 times. In this question, we have 4 groups of 3, which means they're asking us to write 3 plus 3 plus 3 plus 3 4 times. 3 times 5 can be represented as 3 rows of 5 dots. This is called an array, a set of objects or numbers arranged in order, often in rows and columns. If you have a Master Bible Guide, it's a good idea to record this definition of an array along with an example, possibly this one here that you have on the screen, to help you remember. I also recommend that you write on your example that rows go across and columns go up and down. This is an important piece of information, not only for this lesson, but in future lessons as well. So here we have 3 rows, 1, 2, 3, and 5 columns, 1, 2, 3, 4, 5. So we can count by 5s 3 times, 5, 10, 15. We could also count by 3s 5 times if we were to count the columns. But in this case, they're asking us to count the rows. And counting by 5s is an easier step than counting by 3s. So they would like us to create an array for the following statements. We're just going to do a few of them. So here, the first number represents the number of rows. So they would like us to have 2 rows of 5 dots in each row. So my smart board is a little off, so it's not showing us nice straight rows, but that is supposed to be 2 rows with 5 dots. In this one here, we have 3 rows of 3 dots. Seems to be a little bit on an angle. So now we have 3 rows, 1, 2, 3, and 3 columns as well. Moving on. Think about, in each array, each row contains the same number of dots. There are 3 ways to arrange 4 dots so that each row contains the same number of dots. So here we have 1 row with 4 in it. So that would be 1 group of 4. Here we have 2 rows. So 1, 2 rows with 2 in each. So 2 times 2. That also equals 4. So same number of dots, just arranged in a different way. Here, we have 4 rows. 1, 2, 3, 4, but there's only 1 dot in each row. So that would be represented by 4 groups of 1. Again, the same answer of 4. So different ways to represent the same number. So I'm going to go back to that for a second. So at the bottom it says, using 6 counters, create and draw as many different arrays as you can. Write the corresponding multiplication sentences. So a good practice for right now would be to pause the video and to, find 6 counters and practice this skill of taking the 6 counters and finding the different ways to arrange the 6 counters so that you can write and then practice coming up with the multiplication statements, which are these. This is a multiplication sentence or statement that they are asking you to create. So we're going to move on to the next screen. That's something that you can try out on your own. And so now they're asking us to create and draw as many different arrays as you can for each total. Write the corresponding multiplication sentences. For this is a different question now. They're asking us to have a total of 8, but we're going to add 2 counters each time to get to the total of 8. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So we've used 2 4 times. So the multiplication sentence would be 4 groups of 2. And we have to remember that a multiplication sign means groups of. Okay, so that's the corresponding multiplication sentence that goes along with the addition sentence that we created. So now we would like to have one that equals 12, and this time we're going to be counting with 4 counters. So 4 plus 4 is 8, plus 4 more equals 12. So we ended up with 3 groups of 4. So the corresponding multiplication sentence would be 3 times 4 equals 12, and this is the addition sentence that goes along with that statement. Find all the arrays that can be made with 12 counters. Show all of the arrays. So this is similar to the activity that we had with the 4 counters and then the one with the 6 counters that I asked you to try on your own. So now we're going to do the same activity with 12 counters. Again, I suggest that you get some counters, pause the video, try this on your own first, record the different arrays that you were able to create, and then check out your answers compared to what I've got on the screen. So the first one way that we can create a group of 12 would be to be a straight line. 7, 8, 9, 10, 11, 12. So that's one row of 12. We can do the same thing, only creating a column of 12. Go the other direction. So now we have 12 12 rows with 1 in each one. So that would be 12 times 1, sort of the reverse of this multiplication statement. But we could also group them in twos. And I could have 2 rows. And if I have 2 rows, we know that 6 plus 6 would make 12. So I would have 2 rows of 6. And I can do the reverse. I can have 6 rows with 2 in each. And that would be 6 times 2. We also could have 3 rows with 4 in each. Sorry, they're not, once again, our smart board is a little off, and that would be 3 times 4. And we can have the reverse of 4 rows with 3 in each. And then we would have 4 times 3 equals 12. The question here, though, is how do we know we have all the arrays for 12? We can make an organized list showing the number of rows. Since we know that the maximum number that we have is 12, we can start with 1. And we know 1 times 12 equals 12. We discovered that 2 times 6 equals 12. We know that 3 times 4 equals 12. And we know that 4 times 3 equals 12. So I've used 1, 2, 3, 4. Question is, can I use 5? Can I create an array that has 5 rows and get to 12? If we try that, 5 plus 5 is 10, and 2 more would be 12. Well, that's not a complete array because we are missing 3 here to complete the array, and yet that would take us bigger than 12. So we can't have 5. So 5 times nothing equals 12. So we can't use that one. 6, we can use 6. We've discovered that up at the top. So we can have 6 times 2 equaling 12. So then 7. Can I have 7 rows going down? And if I did that, another 7 would actually take us bigger than 12 because 7 plus 7 is 14. So that won't work either. So I cannot have 7 times anything equaling 12. 8 plus 8, if I tried 8, that would not work. 9 plus 9 would be 18. That would not work. 10 plus 10 would be 20. That wouldn't work. 11 plus 7 would be 22. So that wouldn't work. But we can have 12 times 1. That would be our last factor, our multiplication statement that would equal 12. So 12 times 1 would equal. So as long as I use an organized list and go through each of the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, we tried 10 and 11, they didn't work either. So we know these ones don't work by ruling them out. With 12 counters, the highest number of rows is 12. All of the arrays of 12 are 1 times 12, 12 times 1, 2 times 6, 6 times 2, 3 times 4, and 4 times 3. When you have found all the possible arrays, you have found all the factors of 12. Again, this is another word to add into your math survival guide. You might want to pause and copy this definition. The factors of a number are the numbers that multiply to give that particular number. And you can use the example down at the bottom here that 1, 2, 3, 4, 6, and 12 are the factors of 12. So those particular numbers multiply together to get 12, or can be used in multiplication statements to get 12. There are only two arrays for the there are only two arrays for each number. So I think we've missed a slide in there that's sort of disappeared. So they were looking at some numbers that don't have this many factors. So if I had the number 2, if I was to find an array to organize for the number 2, I could have 2 dots going in one row, or I could have 2 rows with only 1 dot in them. And so I would have 1 times 2 or 2 times 1 equaling 2. The number 3, if I look at the number of dots that I can create for that, again, I can go 3 across or 3 down. Again, 1 group of 3 or 3 groups of 1 equaling 3. But there's no other way that I can multiply a number to get 2 or to get 3. They looked at the number 5, and we know the number 5 is the same way. I can only have 5 dots going across or 5 dots going, 5 dots going down or 5 dots going across. So those also would only be one factor, 1 times 5 or 5 times 1. So there are only 2 arrays for each number. Numbers that have only 2 distinct factors, 1 and the number itself, are called prime numbers. So this is, again, another definition that I suggest you put into your math survival guide, which is prime numbers. And you can use the examples, as you can use the example they've given you here, which is 7 is a prime number because only 1 times 7 and 7 times 1. The number 7 only has 2 factors, so 7 is a prime number. So 5 and 3 and 2 were also prime numbers. 4, however, wasn't a prime number because we discovered that we could have 1 times 4, but we also could have 2 times 2. So it had more than 1 and the number itself. Numbers that have more than 2 distinct factors are called composites. So 12 is an example of a composite, so would 4 and 6 be composites. The number 1 only has 1 factor, so it's neither a prime nor composite. So I do recommend that you put a definition about composites into your math survival guide, and also this information about the number 1. Now it's asking us to draw some arrays. This is the screen that we've already sort of looked at, so we're going to surpass that. We're going to draw some corresponding arrays for 2 times 4. So we're looking at 2 rows with 4 in each row. And that gives us the 8 that they're showing us here. 5 rows. So the first number is the number of rows, and the second number tells us how many in each row. And we have 2, 4, 6, 8, 10 dots. So now we're going to look at some word problems and see if we can come up with the arrays to help us solve the word problems. There are 3 rows of desks. There are 4 desks in each row. So we'll do our 3 rows of desks, 4 desks in each row. That's the array that we have to help us solve that. How many desks are there altogether? So let's look at the multiplication statement that would go with that, which is 3 times 4. And if we count up the dots, we can see that there are 12 dots. So the answer would be that there are 12 desks altogether. The word altogether you've seen before when you've been doing addition word problems. So something to note that when we are dealing with the word altogether and we're dealing with multiplication and addition, our answer is always bigger than the 2 numbers that we are using to multiply or to add with. which is the opposite of when we're using, when we're subtracting, because our answer in a subtraction or division question, the answer would be smaller than the first number. And that's something to remember, that multiplication will produce a bigger number, and we need to always check our answer to see that it is indeed a bigger number than the other two numbers that we are starting with at the beginning. Moving on. Here they're showing us two arrays, and they're showing us that if we add up the numbers on the columns, sorry, in the rows, we would add up 5 4 times. And so the multiplication statement would be 4 groups of 5. Here, they're asking us to actually add in the direction of the column. So we're going to add 4, and we were going to add 4 5 times. So our multiplication statement would be 5 times 4. And you'll notice the answer is the same. So does counting the columns instead of the rows change the number of dots in the array? Well, looking on that last screen, it doesn't. 20 here and 20 here. So it doesn't matter which direction we go. 4 times 5 and 5 times 4 are the same number. They are. So yes. What symbol do mathematicians use to show that two numbers or statements are the same? We use an equal sign to show that those two statements, 4 times 5 and 5 times 4, equal each other. Okay, which also means they equal the same answer. You can see the same thing by rotating an array. You get the same answer regardless of the order in which you multiply a pair of numbers. So here we have one array with 4 rows. Oops. And here we have the same array only turned on its side, and this time it has 5 rows, but the number of dots in each row differ. Same answer though, because if you count up the dots, you get 4 times 5, and you get 5 times 4, you get the answer of 20 each time. And that's where we're going to stop today.